So these fractions that we get from definite integration, it's probably two main ways you can go about it. I'll solve this one two different ways, and then you can think about what's easier for you. So in the first method, I'm going to try and figure out what this fraction is and then subtract whatever this fraction is. So I'll do 3, so just evaluating all these powers. 3 squared is 9. Okay, and then I have 4 on 8 as well. Okay, so I'm thinking 4 on 8, I could probably change that to a half, but I've got 8s elsewhere, so I may as well just try and keep everything in that same denominator. I've got to convert 3, so it's got a denominator of 8, so I need to multiply that by 8, so 24 on 8. Okay, that guy stays the same, and 2 I need to convert into 8s as well, so 16 eighths. Okay, so trying to simplify these fractions. 24 minus 9 is 15 eighths, and then I'm subtracting 12 eighths. So I end up with 3 eighths. Okay, so you can see how in that method some of these fractions and numbers might get pretty big. Let's see what happens with the alternate method. So the alternate method starts the same. Evaluate the powers. But instead of trying to figure out those two fractions, we're just going to expand this negative. So it's subtracting two things. So from here I'm subtracting 2, and then I'm also subtracting negative 4 eighths. So I'm really adding 4 eighths. So then I might be able to just look at these numbers. So remember, the number owns the symbol to the left. So I have positive 3 and negative 2. I can just subtract those numbers for 1. And then looking at those fractions, I've got negative 9 eighths plus 4 eighths, which ends up as 5 eighths. Correction, negative 5 eighths. And then I can just imagine 1 whole, take away 5 eighths, and I have 3 eighths remaining. Okay, so it's really probably a bit of experimentation to see which method works better for you. A lot of the time it's easier to just expand this negative across the however many terms you have in the second part of the integral, and you might be able to solve the problem and not make many mistakes and not end up playing with huge numbers either in your numerators.